We see a new topic today. It is recursion. Okay, this is Unit 3. So we are going to start with recursion. Now let's first have a look at the definition of recursion. So what do you mean by recursion here? You can say that the definition is a function which calls itself repeatedly is called recursion. Now you people have studied functions in C programming. Now, when we talk about functions, there are three things that we need to understand. We have the function prototype, then we have the function call, and then we have the function definition. Okay, so I hope you are aware of these three terms, that is function prototype, then function definition, and function call. Now we know that when we talk about functions, we from the main function. Main is the first, the most important function from which the program execution begins. The main function, in the main function, we usually try to write or we try to call different functions. Like main function can have, it can have a function call to addition. It can have, say, another function call for subtraction. But then when we talk about recursion, in this, the function is going to call itself. Okay, the function is going to call itself. Now, how do you understand this? Whenever I say function, you try to imagine or you say that we have used functions previously, and from the main function, we are trying to execute a different block of code which is written separately after the main function. This is what we try to understand in terms of functions. But when we talk about recursions, recursion meaning the same function is calling itself. It is like I am calling myself, I am dialing my own number. For example, when you take your handset and you try to dial a number, you will usually try to call a different person. Okay, you will try to dial a different number. But when we say recursion, here for real life scenario, it would be like I'm trying to dial my own number. Okay, so that will be called as a recursion, in which a function is calling itself repeatedly. So we know that again, okay, we have when we say that we need to execute a program or we need to execute certain set of statements, there has to be certain condition wherein the program execution comes to an halt. The program execution stops. So in recursion also mentioning this term is important. So before we dive into that criteria, let's first see which are the different types of recursions we have. First one you can see here is going to be your direct recursion. So what is direct recursion? Function calls itself directly again and again. Okay. We will just see this code snippet that is here in red color. Now you see here, we have a main function, like the normal convention, we try to write a C program, we begin with the main function. So what statement do I have within the main function? I am just having a printf statement, hello. This is the first statement in my main function. There are no variables, nothing, directly I am printing. But after the printf statement, what is the statement that I have? I again have a function call. This is a function call. But this time, what is the name of the function here that I'm trying to call? It is the main function again. The same function is calling itself. It is like the one person, like assume one person is trying to dial his own number. Again and again, repeatedly he is trying to dial. This is like a circle which is continuously running. If you try to recall again, whenever we write main, okay, just try to recall, we write the main function, and within that we declare the variables, we write the printf statement or any other statements, and if we have a function call, here we would write a different function name. Say we are trying to add two numbers, so we would say here add. If you are trying to calculate the subtraction or the difference between the two numbers, we would have a different function here. But never have we ever written a code wherein the same function is trying to call itself. So here you can see that the next statement we again have is main. So from this main function, what is going to happen when this execution comes here? It comes back to this function again. So again here printf is going to be executed, then again the same function. So what is happening? Repeatedly this printf statement is getting executed. So if you see the definition here, a function which calls itself repeatedly, the main function is calling itself repeatedly. This is called as recursion. Did you follow this much?
Yes, ma'am.
Okay. Have a look at this particular program. Okay, we have done this before. This program about linear search, making use of functions. I hope you all remember this. Just we will not go in detail. Just have a look here. We have the first, that is, we start the execution from main. Okay. After these set of statements here, after these set of statements, we come here. We come to this particular line number 17. So can you tell me what is this linear search? Position is equal to linear search, and I'm passing 3 parameters. So what is this?
It is calling the function linear.
Function calling.
Correct. So you are like you're given the right answer. That is the main function. In the main function, we are trying to call another function. Which function is that? That is a linear search. So when we come to this line 17, instead of executing, trying to complete the code here in the main, we come to line number 26. The execution comes to line number 26, where the actual code for the function is written. That is, this is called as a function definition. Okay, from line number 26. So the block of code here is for the linear search function. But if you, I told you when we talk about recursion, let us go back to that slide. So have a look here, what is happening? Instead of, in the main function, instead of writing some other name, instead of trying to call some other function, I'm calling the same function only. I'm calling the main function only. So this is going to be like, this main function is only calling itself. No other function is there. So repeatedly and now and then this printf statement is going to be printed. So this is called as a direct recursion, in which the function, a function, for example here main, the main function is calling itself. Another instance we have, that is called as indirect recursion. So this is a process in which the function calls indirectly again and again. Okay, let us understand this with this code that we have here. Okay, just observe, assume that there is the function main, and within the function main we are writing all this. For simplicity, just I have taken here 2 functions. One function is p. Now, in this function p, what am I trying to do here? I have just called a function q. So p function is calling q. So when we come here to this q, the code of or the line of execution will come to the q function. But if you observe again, in the q function, what is there? Again a call to the p function is there. So this is like there are, you can say that you have 2 different functions. In this instance, we have 2 different functions. These functions are executing repeatedly. So the criteria or the definition for the recursion is true. They are executed repeatedly. But how are they getting executed? It is not like the previous one. It is not like direct recursion, wherein the p function is calling itself. It is not like that. Here, the function p is calling q, the q function is calling p. So indirectly, this is happening indirectly. The function p calls the function q. When we go to the function q, the p function is called. Whereas in the previous instance, the same function is calling itself. Okay, so this is another type that is called as an indirect recursion. So indirect recursion or direct recursion, one important thing to understand is the functions execute or the functions are repeatedly calling itself. So we have 2 types there, direct recursion and indirect. When we talk about the direct recursion, it is going to be like the same function is calling itself. The same function is calling itself. Then when we come back to the indirect recursion, here it is like two functions, or it is not like the same function which is calling itself, but two different functions are calling each other. But again the execution is happening repeatedly. So it is called as recursion. Did you follow these two types?
Yes, ma'am.
Okay. Okay, we'll see one simple program. Before that, let's just see one important point about this, that is called the base criteria. Okay, what is this base criteria? Let's first read it. So there must be at least one base criteria or a condition such that when this condition is met, the function stops calling itself recursively. To understand this, okay, we'll come back here. Okay, now if you have a look at these set of statements, okay, do you think that this particular program will work correctly? Can anyone tell me, will this program work correctly?
Yes, ma'am. But hello will be printed infinite.
Correct, very good. What is going to happen is printf statement, that is hello, is going to be printed infinite times. Or you can say, like, you make use of the terms infinite loop wherein there is no condition where it should stop. So the program is going to execute, but printf statement will continuously be printed and the program is not going to stop. The program is not going to halt because we have not mentioned any base criteria. Base criteria is just say that it is like a condition or like a statement which will stop the execution of the program. And also we just when I say stop the execution of the program, I would also mean that with the correct output. There has to be a condition. When that condition is mentioned in recursion, the program execution comes to an halt, or the program execution stops its working. So that is called as the base criteria. Now, let's quickly move to a simple, very simple example. Okay, the program here is you can say that we are trying to multiply two numbers using recursion, or we are trying to find the product of two numbers using recursion. First, let us have a look at the code and then we shall do the tracing. So have a look at first the code at line number 4. What is this? Int multiply, int comma int. This is the function prototype. Let me write here. This is going to be the function prototype. Next, we have the main function wherein the normal control of execution is going to be. So you have variables declared here, m, n, and res, that is result, to store the multiplication of or the product of two numbers. Next thing is we are going to prompt the user to enter two numbers and we are storing them in the variables m and n. Now, when we come to multiplication, we know that if either of the number is 0, if I try to say, for example, I try to multiply 4 into 0. Two numbers are 4, comma 0. What is going to be the product of these two numbers? Can you answer this? Do you know the whenever we try to multiply a number by
0.
Yes, 0, right? So the product of any number multiplied by 0 is going to be 0. So here we are trying to check for that condition. We are going to check whether our number m is equal to 0 or n is equal to 0. If either of the number is equal to 0, which means multiplication is 0. Okay. Suppose the product, or we say that the number entered by the user is, even the m value is not equal to 0 and n is also not equal to 0. These are the two numbers that I have entered. Let me write m is equal to 4. Let me say n is equal to 5. So, in the else part, what are we doing here? What is this statement? Result is equal to multiply n comma n. This is our function call. We are trying to call a function. The function is multiply. Okay. And what is this res? This is the return type. This function multiply is returning the result, which is of type integer. You can have a look here in the function prototype. Just observe the cursor movement. At line number 4, you can see that we have declared the prototype int multiply, right? So here also the same function name. Result is going to be the return type, which is of type integer. Two parameters are there, both are of type integers. So two parameters that I have passed are m and n. And for the sake of simplicity, we shall just stick to entering integer kind of numbers. So once this function call at line number 16, we reach here, we need to go to the program. The program here is a function definition. So here we are going to execute this code in terms of recursion. Okay. So you can see here again the same signature is there, the function name, the return type of integer, two parameters which are going to be of type integer. Now, in the first part, that is here, we are checking if a particular number, either of the two numbers, either m or n, right? Two numbers we enter. So, in that two numbers, if the second number is equal to 1, what is going to be the product? Suppose I say that I enter the number as 4, 1, right? X, how it is going to be mapped? M, the variable m is going to be mapped to the variable x, and the variable n is going to be mapped to the variable y. So we know that if we can say that if the second digit, or even you say the first one, okay, either of the two numbers is 1, we know that the product of this is going to be equal to the first one. That is, we are assuming in this case, we are checking the condition for if the second number is equal to 1, then the product of this 4 into 1 will be 4. So that is why we say return x. Return x means we are returning the first number. Instead of 5, say that I have entered the second number as 1. So what is going to be the product of 4 into 1? It is going to be the first number. That is x. So we are saying here return x. Is this much understood?
Yes, ma'am.
Right. Now, coming to the else part. Observe this statement. Return x. X is the first number. Plus multiply. Multiply is what here? Multiply is our function. The function which we have declared, and with the task of this function is to calculate the product of two numbers. So this function is calling itself multiply. We are again passing two parameters, but this time see the first parameter is same, it is x, but the second parameter, that is we are reducing the value of y, that is n here, we are reducing its value, we are decrementing its value by 1. Let us trace this. Let me take back the particular numbers as 4, 5. Okay. Now, basic understanding. Okay. When I say product of two numbers, how are we trying to do it? Basically, one number. If I say 4, 5, the product of this is going to be 20. Correct? So what we are trying to do here? We are trying to add the number 4 5 times, right? If I say 4 plus 4 What is the sum of this?
$20.
20. Is it equivalent to 4 into 5? That is, I am trying to add the number 4 5 times. Correct? We usually will, for multiplication, we would just write it like this. Right? This is equivalent to this. The number 4 is being added 5 times. So we write 4 into 5. So if you have a look here, we are doing the same thing. The first number, the first parameter should be added 5 times here. Okay, but we are just calling the function once again. Let us try to trace this now. Let me just show this demonstration in the Excel sheet. So what are we trying to write? We are saying return x plus the function multiply. Again we have x comma y minus 1. Correct? Just see, is it correct what I have written here? Are you there, students?
Yes, ma'am.
Let us start, okay now. Let me write the input for you all once again. Let the value of m be equal to 4 and the value of n I have entered as 5. These are the two numbers. Now, when I say return x, what is the value of x?
4.
Correct? So it is, let me write the statement. Return, it is going to be 4 plus, okay, multiply value of x is 4, comma, y minus 1. What is y minus 1?
4.
4. Now, this function multiply is again calling itself, okay. So what, again the next statement, just observe what I am writing. Again I am going to write return. So this time we are trying to just execute this one. We are trying to execute this. So this time the value of m is equal to 4 and the value of n, or rather let me say the value of x is equal to 4, the value of y is equal to 4. Is it correct? Is this statement that I have written, is it correct?
Yes, ma'am.
Yes, you are able to understand it. Now let us again see, we did this first time, okay. First time the values were 4 comma 5, that is the original values that were passed were 4 comma 5 and y minus 1, so it is going to be 4. Next time again return. So what is going to be returned now? The value of x is same plus the function again multiply, which is calling itself. The value of x is same. This time the value of y, 4 minus 1, it is going to be 3. So what is the updated value of x now? The value of x is 4. The value of y is 3. Again next time return, it is the value of x is same plus multiply, the value of x is same. What is going to be the updated value of y now?
2.
Correct, it is going to be 2. Let me update the values and write here. So x is still 4. The value of y is decremented to 2. Okay. Now, if you say 2 minus 1, the value of y is 1. Now pay attention here, when the value of x is 4 and the value of y becomes 1. Let us come back to our program. Have a look here, how we executed. Okay, let me write in comments here. First time, you know that we passed x is equal to 4 and we passed y is equal to 5. The value of x and y were, let me write it here itself on the top. So does the if condition become true for this when the value of x is 4?
Yes, ma'am.
Does the condition if become true for the value of x equal to 4 and y equal to 5?
No, ma'am.
No. The else part is executed. We repeatedly executed the else part. Okay. At the last stage, we reached a place wherein x is 4 and the value of y has become now equal to 1. So what is this statement saying? If y is equal to 1, if y is equal to 1, what do we need to return?
X.
X, which means we need to return 4. But where? Where is this 4 getting returned? Once this part executes, I will write the updated value here. Okay. The value that is going to be returned will be 4 plus we have to return only for this function multiply. Only for this. When the value of x is 4 and y is 1, the value that needs to be returned is going to be equal to x. So it is going to be 4 plus 4. This function multiply is returning only this 4. Have a look here once again. When the value becomes equal to 1, we need to return x. So we are returning 4. So this particular function is returning 4 plus 4, which is 8. So where is it returned? Let me make use of the annotation here. This is returned to the previous function here. Okay. So here, what again equal to, let me write here. So this is going to be equal to this 4, okay. This 4 that I have, let me write is equal to 4 plus this 8. This 4 plus 8. From where are you getting this 8? Can anyone just confirm me once again? From where did we get this 8?
Multiply of 4 into 2.
No. There is no multiplication of 4 into 2. This 8 has come from this function.
Ma'am, how it is returning the value to previous one?
Because this, see, when we came to this, understand the hierarchy, okay? This multiply 4 comma 2. When I say multiply 4 comma 2, the function multiply is getting called again. So multiply, when I say again 4 comma 2 here, I am passing new values. The new values that are going to be passed here is going to be 4 and 2. 4 and 2 is getting passed. So your if condition is false, which means you will execute the else part. So you are executing the else part. In the else part, the multiply function is getting called again. So when you pass 4 comma 2, the value is going to be what again here? Y minus 1. So the new value that is passed here is 4 comma 1. So what is happening? Where are you returning? Every time the same function multiply is getting called again and again. So that is why here, when I said 4 comma 1 and this becomes equal to 8, So this is going to be returned to the function which called itself. Isn't it? What is the definition? Where do we return? Otherwise also normally, where do we return after the execution of the function, where would we return the values? We are returning to the function that has called itself. Or have a look at this program. Okay, when I finish the execution of this linear search, where am I returning this -1? I am returning it to this, right? To this function which has called. That is, I am returning it to this position. But in our case of recursion, the same function is calling itself. We would return in this case, in that linear search, we would return it to the main function. But here, the same function is being called again and again. So you will be returning it to the same function. See, maybe do not worry if you have not understood it now through this online, tomorrow again in the class I will trace it on the board. So maybe that time it will be more easy to understand. So here you have, I just complete this. So you have 4 plus 4, which is going to be 8. So this will be returned to this, which is going to be equal to the first x value plus multiply of 4 comma 2. So what is going to be the value of 4 comma 2 that we have got here is, that is 8. Now this 12, this total 12, okay, that will be returned to this function. That will be returned to this function here is equal to 12. So this was 12, 12 will be returned here. So again it is going to be equal to 4 plus 12 that we got from this function, which is going to be 16. Now this 16 is again returned here. So this is going to be equal to 4 plus 16. So you can see here the multiplication of, or the product of 4 comma 5 will be equal to 20. Are we getting the correct result? Is the product coming correct?